This is question number 24 from the 2016 practice exam, and we have a limit, but the functions are a little different here. So if we use direct substitution, first of all, that's going to give us tan 0 over, now on the bottom, e to the 0 is just going to be 1, so this is going to be 3 minus 3, and we're going to end up with 0 over 0. When we get 0 over 0, one of the things that we would look for would be to factor. Well, this obviously isn't going to factor very easy, but another one, now that we have derivatives, is L'Hopital's rule. And L'Hopital's rule says that we can take the limit as x approaches some value of a of f of x over g of x is going to be exactly the same as the limit as x approaches a of the derivative of f of x over the derivative of g of x. So if we take the derivative of the top and bottom and then substitute in a, in this case 3, we should get to the same limit. Alright, so let's try this again. Let's just scroll this up. Alright, so we're going to try by taking the derivative of each of these. So I have tan of x minus 3, so tan x minus 3. Well, if I take the derivative of that, we're going to take d dx, that's going to give me secant squared x minus 3. And then I'm going to take the derivative of the bottom, which is 3e to the x minus 3 minus x. Well, the derivative of this first part here is just going to give us 3e to the x minus 3 minus 1. Alright, now that we've taken the derivatives, let's put this back into our limit and recalculate again. So I'm just going to scroll up to our question. So now this whole limit here we've changed, and it becomes the limit as x approaches 3 of now secant squared x minus 3 all over 3e to the x minus 3 minus 1. Okay, direct substitution. Now if I put a 3 in here, this whole thing becomes 0. Secant squared of 0, remember secant squared is 1 over cosine, so cosine of 0 is 1, so this will be 1 over 1, which is just 1. Let's put in our 3 here. Again, that is 0. E to the 0 is 1. 3 times 1 minus 1 is 2, and our answer now is 1/2. So when we get some kind of crazy equations here, it's still going 0 over 0, we can't factor, we can now use L'Hopital's rule. Take the derivative of the top, the derivative of the bottom, and then reevaluate.